All right, stoichiometry review problems. We are going to start with our most basic, moles to grams. Anytime you're trying to connect moles and grams, or grams to moles, you use those periodic tables. What is the mass of 1 mole of boron? First things first, mass means grams. Okay, it's what you use on a balance, right? So what do we have here? We have 1 mole of boron. And you do what you always do. Take this and put it down here. One mole of boron is how many grams? And you just look at your periodic table, find boron, and it's 10.811. Of boron. You could just do B, a symbol. And that is our answer. Cancel these out. All right, so if you're sitting there going, oh my gosh, do we have to show our work for that? It's literally just looking it up on the periodic table. No, you wouldn't have to show your work for this. I'm just doing the process. Trust in the process. All right, so what is the mass of 4.43 moles of silver nitrate? All right, so what do we have? We have 4.43 moles of silver nitrate. And what's the process? Always trust the process. You take whatever it is right here and you put it down there. Always. Every single problem you do, that is what your job is. So I'm going to go moles, AgNO3. Now, what do I want? I look back at the question. We want the mass. That's grams. So we can go moles to grams, grams to moles. We look at our periodic table. And what you do is you just look up the mass of silver, which is about 108. The mass of nitrogen, which is 14. And oxygen, we know, is 16. But we need that 3 times, right? And we add all of those up. So that's 170 grams of silver nitrate. And so if 1 mole, and it's always 1, for the moles, when you put them in the equation, it is always going to be 1 mole unless you're doing mole-to-mole relations. When you're doing mole-to-mole relations, you look at the balance equations. So, but otherwise, you always have 1 mole. And you literally just look up in the periodic table what the mass of 1 mole of the thing is. Now, we can cancel out our moles of silver nitrate, and we have 4.43 times 170. And you can just put that in your calculator. And apparently my calculator says that's 0. Times 170. And we get 753.1. 753.1 what? Grams of silver nitrate. And that's my answer. And when your answer is all like, something like that just happened, just circle it. It makes it very clear. Yay, circle the answers. Make Jensen's happy. If I have 270 grams of water, how many moles is that? Well, trust the process. What do we have? We write down what we have. 270 grams of H2O. So, as I said, trust the process. What do? We take what we have here and we put it down here every single time. And so we have grams. We want to know moles. So 1 mole of H2O. How many grams is in 1 mole? Well, grams to moles, we look at our periodic table. Okay, we look up hydrogen has a mass of 1. Oxygen has a mass of 16. So water would have a mass of 18. Because it's 16 plus 1 plus 1. There's 2 H's. And 270 divided by 18 is how many moles of H2O we have. And that is about 15. There we go. All right. Avogadro's number is how many particles or atoms are in 1 mole. Okay, that's a very important distinction. Remember, make sure to add on your stoichiometry, buddy, that 1 mole is 6.02 times 10 to the 23rd. And this can be, sorry, there we go. This can be with the mole on top and the molecules on the bottom, or you can flip it and have the molecules on top and the mole on the bottom. Whichever way you need it in your equation, you can have it that way. Why? Because this is equal to this. They are the same thing, so you can flip them if you want. All right, if I have, and let me just angle my camera a little bit here. If I have 5.3 times 10 to the 24th molecules of water, how many moles of water do I have? You can't shorten that because if you shorten it, it looks like moles. Sorry. All right. Step 1, trust the process. Take this, put it down here. And I want to know moles. So 1 mole is how many molecules? Well, bing, 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 bing. 1 mole is that many molecules. All right. So now we got to know how to divide 5.3 times 10 to the 24th. Divided by 6.02 times 10 to the 23rd. And my unit is moles of H2, but I'm going to write that at the end, okay, because we've canceled out these. So what you do is you take this coefficient, this number right here, and divide it by this number right here. So 5.3 divided by 6.02 gives us 0.880. Now, to divide these, you just keep the times 10, and you take this and go 24 minus 23. And so that is equal to 0.880 times 24 minus 23 is 10 to the 1. So 10 to the 1 is the same thing as 10. So it's really like this times 10. Okay? When you have just 1, you just multiply it out. If you can do it in your head, great. Otherwise, use your calculator. 0.880 times 10 is 8.8 moles of H2O. Remember I said this was our unit right here, moles of H2O. So I got to remember my unit in my answer. And that is my answer. Now, if you need to be reminded how to multiply or divide numbers that have these big, huge exponents in there, in your stoichiometry buddy, I did a whole section multiplying scientific notation. when you multiply them, it's really similar. You just take the coefficients, the 4 and the 2, and multiply those times each other. That gives you 8. Then with the powers, what you do, instead of subtracting them like you did before, you add them. So if you have 10.3 times 10.2, that's the same thing as 10.5. And now you bring it all together. And of course, that's where the hole puncher landed. So really, it would be 8.0 times 10 to the 5th is your answer on that. And then there's another example and more. And then on the back, there are examples on how to divide scientific notation. So that gives you all of that. So don't forget, your Stoich Buddy can be used on the test. And not only that, but on your Stoich Buddy, I wrote 1 mole equals this. And I did it just as an equals. And for some people, it didn't translate that they could use it like this. 1 mole is 6.02 times 10 to the 23rd. Molecules, particles, atoms, it doesn't matter. And that you can flip it. So if you would like to rewrite this on your Stoich Buddy to be have a numerator and denominator, you can. All right, let's get back to this. And let's pick up the pace a little bit. It's going to be a long video. All right, container has 1.5 moles of hydrofluoric acid. So 1.5 moles of HF. I should have put the symbol in there, but I didn't. Sorry. How many molecules? All right, so we got moles. We want to know molecules. First step, trust the process. Take what you have, stick it down there. Every single time. Look, every time. Take what we have, stick it down here. Take what we have, stick it down here. Take what we have, stick it down there. Take what we have, put it down there. Every single time, that's what we do. And there's not going to change. Just do it. All right. Moles, HF. All right. It's asking about molecules. Anytime it asks about molecules, atoms, or particles, your brain needs to think Avogadro. All right, so moles, 1 mole of HS is how many molecules? 6.02 times 10 to the 23rd. Molecules, it's a pain, but you have to write it out, of HF. All right, so now we can cancel out our moles. Woo, woo. And we do 1.5 times 6.02 times 10 to the 23rd, and that is our answer. All right, 1.5 times 6.02 is 9.03. And you just bring the 10 times 10 to the 23rd. Because there's no other big old exponent, so you just keep going with that. Oops, I didn't circle that. All right, mole-to-mole relations. Look at the balanced equation. If I have 3.5 moles of water, how many moles of NH3 will I make? Well, what do we have? We have 3.5 moles of H2O. All right, follow the process. Take this, stick it down there. Now, we need to switch from water to ammonia. Anytime you switch from one substance to a different substance, the way to do it is to go to Moleville. Now, we are already in Moleville. We have our moles. So now we just got to do mole-to-mole relations to switch from one thing to the other. That is the only way to do it, is mole-to-mole. Okay, so if the question is telling you you have one thing and asking you how many thises of something else you have, you always got to go mole-to-mole to switch from one thing to a different, from one compound to a different compound in the balanced equation. So I have moles of H2O. That's what I start with, is moles of water. I need moles of ammonia. So if you are going mole to mole to switch our substances, mole to mole, if mole is above mole to mole relations, we look at the balanced equations. So moles of H2O, well, let's look at this. Here's H2O, and it's got 6 moles. moles of NH3. Here's NH3, and there are 2 moles. So that is the mole-to-mole relation. This is the only time you don't just do 1 mole. Anytime it's moles over moles, you look at the balanced equation. All right, so 3.5 times 2 is 7. 7, and then we cancel out these guys right here. And we have 6. So 7 over 6 moles of NH3. All right, and that's going to be like 1 point something. Okay, so that gives us 1.2 moles of NH3. All right. Sorry, I had to type in my password on the computer because for some reason my computer went to sleep while I was doing this. All right. In the reaction above, I have 2.3 moles of BaN2. How many moles of BaOH will I make? All right. 2.3 moles of Ba3N2 is what I have. So I take that and put it down here. Now I want to go from BaN2 to BaOH, so mole-to-mole relations. And let's look at the balanced equation. BaN2 is 1. BaOH is 3. So my answer will be 2.3 times 3, which is 6.9 moles of BaOH. All right, excellent. Next page. If 20 grams of potassium were to explode with excess water, how many moles of hydrogen would be produced? So we have 20 grams of potassium. All right, do what we always do. Get rid of it. Grams of potassium. Now, we are switching from potassium to hydrogen, so we're going to have to go to moleville. So let's get to moleville as fast as we can. 1 mole of K is how many grams of K? And don't switch to hydrogen right now because you're doing grams to moles. You have to stay with the same substance. The only time you can ever have 2 different substances is if you're going mole to mole and using the balanced equation. So how many grams are in 1 mole of potassium? Well, you just look at your periodic table. 39.098. Remember, we're not worrying about how we're going to round. All right, so now we got rid of that. We need to do mole. Okay, remember, every single time we're taking what we have here and we're sticking it down here. Take what we have here, stick it down there. Always, 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 always. All right, so now we are in moleville. We have moles of potassium. So now we can go mole to mole and switch our substance. We want hydrogen, according to the question. So mole of hydrogen. For mole-to-mole relations, we look at the balanced equations. We have 2 moles of potassium, and we have just 1 mole of H2. Remember, it's Brinkelhoff, so we have to do H2. So we have 1 mole of that. And so now we ended up with moles of hydrogen, and that's what we wanted. So we can cancel that, cancel that. So 20 times 1 times 1 is 20. And 39 times 2 is 78. Oops, why did I put the grams? We didn't have that. We canceled the grams. Canceled, 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 canceled. Okay, so 20 divided by 78. Is 0.256, so we'll round it to 0.26 moles of H2. Kidney stones can form in the human body if too much soda is consumed. Phosphoric acid can react with calcium nitrate to form a painful solid. This happened to my mom from drinking too much Diet Coke. How many grams of phosphoric acid are needed to react with 85 grams of calcium nitrate? All right, what do we have? 85 grams of calcium nitrate. So we have 85 grams of calcium nitrate. All right, we'll do what we always do. Get rid of it. Now we want to go to moleville. We always want to go to moleville. So, mole of CaNO3. Now, always 1 mole. Unless you're mole to mole, it's always 1 mole. So now what do we got to do? We have to use our periodic table to look up the mass of calcium nitrate. I am going to just cheat and use my TA's paper. All right. So 164. I'm going to trust him. 164 grams. That looks about right. Calcium nitrate. All right, so what do we do next? We do the same thing we always do. We take what we have here and we put it down here. It's a lot to write. I know it's a lot to write, but it's okay. Hey, guess what? We are in Moleville. What can we do in Moleville that we can't do anywhere else? We can have mole-to-mole relations to change what our substance is. All right, and what do we want our new substance to be? Let's go back to the problem and make sure we get it right. How many grams of phosphoric acid are needed to react with the calcium nitrate? So we want the phosphoric acid. Now, if you don't know which one phosphoric acid is, like you're doing the test, right, and you're like, I don't know which one that is, ask. Don't just sit there. Ask. All right, it's this one here, H3PO4. All right, so I want to go from moles of calcium nitrate to moles of phosphoric acid. So for mole-to-mole relations, I look at my balanced equation. 3 moles of calcium nitrate and 2 moles of phosphoric acid. All right, and then it wants to know how many grams. Ah, how rude. We have to keep going, don't we? All right, I've run out of paper. Darn it. I'm going to do this just for make sure you understand. Hopefully you guys wrote smaller than me and have more space than I do. Okay, so we took this, we put it down here. Now we cancel it. We took this, we put it down here. Now we cancel it. We keep doing the same thing. Let's take this mole of H3PO4. And what do we want? We want grams of H3. Now, do we know how to have a number here? Grams to moles. We look at our periodic tables. So H3, H has 1. Phosphorus is 31. And oxygen is 16. Let's just see what my TA's paper said that was. 98 grams. All right, now we have grams of phosphoric acid, which is exactly what the question asked for. So now we just go 85 times 1 times 2 times 98. And we get and then on the bottom, 164 times 3 times 1. And we divide. 1, 6, 6, 6. 1, 6, 6, 6, 0. Divided by So it should be like 32, 33. Okay, there we go. Good. So 33.9, and what's our unit? Grams of H3PO4. So there it is, right there, in all its beauty. All right, next one. I have 2.5 times 10 to the 23rd atoms of titanium. And I want moles of titanium. Oh, wow, that's kind of easy. All right, so what do? We take what we have and we put it down there, always. Atoms of titanium. What do we want? We want moles. So 1 mole is how many atoms? Well, that's Avogadro's number. 6.02 times 10 to the 23rd. And so now we just divide. So it's 2.5 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. All right, so 2.5 divided by 6 is about a third. So 0.42. And then 10 to the 23rd divided by 10, that just cancels out because they're identical. So the answer is 0.42 moles of titanium. Container has 1.5 moles of hydrofluoric acid, that's HF. A deadly acid that can kill someone in minutes. How many molecules is this? All right, take this, put it down here. And we want to know molecules. So 1 mole is how many molecules? 6.02 times 10 to the 23rd molecules of HF. Now you just go 1.5 times 6.02 times 10 to the 23rd. All right, so you get 9.03 times 10 to the 23rd molecules of HF. All right, balance the following equation. And how many grams? I'm going to pause this right now, and I'll have a second video with the rest of the questions.